Solar wind. This is the constant flow of charged particles streaming out from the sun in all directions, and it forms the background condition of space weather across the solar system. Most of the time, it is fairly steady, but when it speeds up or becomes more turbulent, it can disturb Earth's magnetic environment and set the stage for stronger events.
High-speed solar wind stream. These are faster bursts of solar wind that often escape from coronal holes, which are cooler, darker-looking regions in the sun's outer atmosphere. When one of these streams reaches Earth, it can buffet the magnetosphere for days and often helps drive recurring geomagnetic activity. Solar flare. A solar flare is a sudden release of magnetic energy from the sun that blasts out radiation across the electromagnetic spectrum, especially X-rays and ultraviolet light. Because that radiation travels at the speed of light, its effects at Earth can begin in just over 8 minutes, often disrupting radio communication almost immediately. Radio blackout. This is one of the fastest space weather effects, caused when flare-driven X-rays and extreme ultraviolet radiation change the ionosphere on the sunlit side of Earth. The extra ionization makes some radio waves get absorbed instead of reflected, which can interrupt long-range, high-frequency communication for minutes or hours. Coronal mass ejection. A coronal mass ejection, or CME, is a giant cloud of plasma and magnetic field hurled out from the sun into space. If one is aimed at Earth, it can slam into the magnetosphere and become the main driver of major geomagnetic storms and vivid auroras. Solar radiation storm. This type happens when high-energy charged particles, especially protons accelerated by solar eruptions, spread through space and reach Earth. These storms matter because they can raise radiation exposure for astronauts, affect satellites, and interfere with radio communication over polar regions. Geomagnetic storm. A geomagnetic storm is a large disturbance in Earth's magnetic field, triggered when solar wind or a CME transfers energy into the magnetosphere. These storms can affect power grids, satellite operations, navigation signals, and they are also the main reason auroras can spread far beyond polar regions. Ionospheric disturbance. This is a broader category for disruptions in Earth's upper atmosphere that affect how radio waves and navigation signals move through it. Even when the effects are less dramatic than a full blackout, they can still degrade GPS accuracy, radar performance, and radio links between ground stations and satellites. Aurora! Auroras are the visible light displays produced when energetic particles, guided by Earth's magnetic field, collide with atoms high in the atmosphere. They are the most beautiful sign of space weather, but they also show that energy from the sun is actively interacting with Earth's magnetic shield. Radiation belt enhancement. Earth is surrounded by regions of trapped charged particles called the Van Allen radiation belts, and strong space weather can pump extra energy into them. When that happens, the belts become more hazardous to spacecraft and onboard electronics, which is why this is an important type of orbital space weather.
Galactic cosmic rays. Unlike most space weather, these particles do not come from the sun, but from outside the solar system, arriving from energetic events elsewhere in the galaxy. They still count as a space weather factor because they change the radiation environment near Earth and can affect spacecraft, astronauts, and high-altitude aviation. Solar cycle. This is the long rhythm of rising and falling solar activity that changes how often flares, CMEs, sunspots, and related storms occur. It is not a storm by itself, but it shapes the whole space weather environment by making some years much calmer and others far more active.